Hello guys, you're welcome to EK Math Academy. I'm continuing doing past paper questions on implicit differentiation. I hope you have watched the first video I made on question 1, which is this question. It was a 7-marker question and a good one. If you haven't watched that, please kindly go and watch it, and you come and you continue with the question 2. Now, should we start doing this question? Find the gradient of the tangent to the curve x power 3 y squared equals to cos pi y at the point -1, 1. That's the coordinate given. Now, it's a 6-marker question. So let us try to do the question. But before doing the question, let me remind you some few things. One is the quotient rule. When you have two functions and you're multiplying together, u is a function and v is a function, and it's a multiplication between them, and you're doing derivative, it's going to be u derivative v plus v derivative u, then v, right? One thing that is it. One thing you have to remember. Now, another thing is what's the derivative of cos x, guys? Derivative of cos x. I hope all of you remember that. You even have that one in your formula booklet, is negative sin x, right? Good. Now, what about if you have cos u, where u is a function? Like maybe you have cos 2x, cos 3x, cos x squared. What do? So you have to remember it's going to be negative u derivative sin u. Don't forget that, okay? These are a few things I'm going to use in this question, and I hope you are ready. Let us dive in the question now. So here it's x power 3 y squared. So I'm multiplying two functions. I'm going with product rule. It's going to be u derivative. Sorry, my function. U is x power 3, and v is going to be y squared. Okay, good. Now, what is u derivative, guys? The u derivative is going to be 3x squared. And what about u derivative? V derivative. This is v. So my v derivative is going to be 2y. Is that okay, guys? Very good. But because it's implicit differentiation, this should be dy over dx. Okay? Good. Now, what about here now? This one is going to be this exactly. So it's going to be negative pi, because the derivative of this one is only 1. Pi is constant, and the derivative of y will be 1. So derivative of cos is going to be negative sign, and that's why I have a negative in the front. So it's going to be sin pi y dy over dx, right? You understand that? Very good. If there's something not making sense, let me know in the comments, okay? Good. Now, can I apply the formula now? U derivative v, u derivative v, 3x squared times y squared. So it's going to be 3x squared y squared, right? Plus v derivative u, that is 2x power 3 y dy over dx. All together, guys? Okay, good. Now, this should be equal to, by derivative of that, which I got as a negative pi sin pi y dy over dx. Is that okay, guys? Okay, check if every step is clear now. Now, when you reach here at this point, everything with the dy over dx goes the other side, and everything without dy over dx goes on the right-hand side. Why am I doing that? I'm making dy, the main objective here is to make dy over dx the subject. But if the coordinate is given, even from here you can substitute there. Where there's x, put there -1, and where there's y, put there 1. Still, you are going to get your derivative. But I always like making dy over dx the subject. Okay, fast forward. So it's going to be 2x power 3 y dy over dx over dx right here. Now plus pi sin pi y. Is that okay? then dy over dx. I've brought everything with the dy over dx one side. That's why this was negative. This time around is plus because I moved it on this side. Then I'm going to take this one the other side. So it's going to be negative 3x squared y squared. Is that okay? Now, dy over dx is common, so I need to factorize that. So I'm going to have 3x power 3 y plus 5 sine pi y. Now everything, because I factorized the y over the x, so dy over the x, guys, are we together? Good. Now this one should be equal to negative 3 x squared y squared. Okay, good. I brought this on the other side, and then I brought this one here. Very good. Now I'm making dy over the x the subject, so I have to divide this everywhere. So if I divide, what do I mean with? I'm going to remain with dy over the x equals to negative 3x squared y squared, guys. Okay, good. All of this over 3x squared y plus pi sine pi y. Okay, out together, guys. Now the question is asking me, find the gradient of the tangent to the curve at what point? Negative 1, 1. So here I'm doing it at t negative 1, 1. Are we together, guys? Very good. Now, where there is x, I put there negative 1. And where there is y, I put there 1. So what do I get? I'm going to have negative 3. This is negative 3. Bracket negative 1 squared, guys. Bracket 1 squared, okay? All of this over 3. This is power 3. Yes, it's power 3. Okay, good. Negative 1 power 3 plus y. Y is 1, right? Okay, good. Let me write it very well for you. Okay, 1 plus pi sine. It's going to be sine pi. Okay, you get that? Because y is 1. Okay, now this is the what sine pi from the unit circle, guys. You should remember that from the unit circle. This is 1, 0 here, and this is 0, 1, and this is the negative 1, 0, and then this is 0, 1 from the unit circle, negative 1. So this is where pi is, and sine is going to be 0. So the whole of this is 0. So what do I mean with negative 3 times 1 times 1? That's a negative 3. And then this one is 3 over, oh, this was 2. Why did I make a mistake? Oh my God, this is 2. Sorry, guys. This is 2. This is 2. So here is going to be negative 2. So the gradient of the tangent is going to be 3 over 2. Okay? I hope you have understood. So thank you very much. Thank you for listening. In the next video, I'm going to do question 3, which is a very good question with 8 marks here. And you can see determining the exact coordinates of the point P on the curve where the tangent line is parallel to, wow, is parallel to y-axis. Very good question. And then I'll try to combine it with question 4, also with 8 marks. So I hope you're enjoying past paper questions on implicit differentiation. If there's a question you don't understand, write in the comments. I will get back to you. So thank you very much. Thank you for watching my videos. I highly appreciate that.